Welcome to the deep dive. We dig into the latest research, pull out the core insights, and basically give you a shortcut to getting up to speed.
Uh-huh.
Today, we're looking at something pretty cool, a new way to generate images of specific things, like your own mug or toy, without needing any extra training or tons of data.
That's right. We're diving into a paper called Flux Already Knows Activating Subject-Driven Image Generation Without Training. It's fresh off Arxiv.
Okay,
And for you listening, especially if you're trying to keep track of AI image generation, think of this as us unpacking the really innovative bits. We're focusing on, the academic contribution, the breakthroughs.
exactly, the aha moments from the research. So let's jump in. What's the fundamental problem these researchers are tackling here?
Well, the main challenge is what's called subject-driven image generation. So imagine you've got, I don't know, a unique toy car.
Right.
And you want the AI to create pictures of that specific car, maybe driving on Mars or underwater, whatever.
Okay, not just any toy car, but that one.
Precisely. And traditionally, getting an AI to do that reliably meant a lot of work. Usually you'd have to fine-tune the model, basically retrain it partly, just for your toy car.
Which takes time, computing power, and you need lots of pictures of the car.
Exactly. The paper calls it excessive fine-tuning and data dependency. They really wanted to find a way around that whole process.
So less effort, more flexibility. Were there already ways to do this without training? Zero-shot methods they were trying to improve on?
Yeah, they mentioned one existing technique in the paper's intro, diptych prompting with ControlNet. It's a way to do zero-shot in painting.
In painting, like filling in a missing part of an image?
Sort of, yeah. You use a couple of images to guide the AI to put your subject into a new scene without specific training. But the researchers here felt they could make it even simpler, more elegant.
Okay, so simplification is key. And that brings us to their big idea, mosaic image completion. What exactly is that? Sounds intriguing.
It really is a clever framing. They basically said, let's turn this into a problem of completing a picture that looks like a mosaic.
Mosaic, like tiles.
Exactly. Imagine a grid, maybe 3 by 3 squares. One square is empty. That's where you want the new image of your subject to appear.
Okay.
And in all the other squares, you just put copies of the original image of your subject, your toy car, for instance.
Ah, I see. So a 3 by 3 grid, one blank spot, and the other 8 spots all have the same picture of my tour car.
You got it. Then they take a standard off-the-shelf text-to-image model. They used vanilla Flux, nothing specially trained for this.
Okay.
And they just ask it to fill in the blank square using basic in-painting. You give it a text prompt, like toy car driving on Mars, and the model uses the context from all those surrounding images of the car to figure out how to draw it in the new setting.
Wow, so it's using the repetition as a really strong visual cue for what the subject actually looks like.
Precisely. The paper shows a diagram, and it makes it really clear visually. The mosaic itself kind of conditions the model implicitly.
That's a really smart way to tap into what the model already knows without retraining. But hang on, they found that just doing this once wasn't quite enough for perfect identity, right? This is where it gets really interesting, innovation-wise.
Absolutely right. That was a key observation, a really core part of their contribution. They found that just repeating the subject image multiple times in that grid, it significantly boosts how well the model preserves the subject's specific details, its identity.
So the more examples right there in the input mosaic, the better the final output matches the original subject.
Exactly. In that 3 by 3 example, having the car in 8 panels gives the model such a strong prior, such clear visual information that it does a much better job keeping the car looking like the car when it fills in the blank.
Makes sense.
And a neat side effect is that this naturally works whether you give it one picture of the subject or even pictures from a few different angles.
Okay, this mosaic idea is clever. How did they package this into like a working system? They call it latent unfold, right?
Yep, latent unfold is the framework they built around this core mosaic idea. They realized this works particularly well, not just with pixels, but in the latent space of the AI model.
Ah, the compressed abstract representation the AI uses internally.
Exactly. So latent unfold applies this mosaic principle in the latent space, and then they added some extra cleverness, enhanced attention mechanisms, which we can get into, and specific ways of writing the prompts
Okay.
to push the quality even higher. And the big achievement, the real headline innovation here, is getting state-of-the-art results for subject generation without any extra data and without any fine-tuning. It just works with the base model.
That's huge for accessibility and efficiency. Let's dig into those technical innovations. How exactly is it framed as image completion? And what's the role of in-painting there?
So yeah, it's framed as completing that one blank panel in the grid. Intainting is just the technical term for filling in missing image parts. They note how intainting tech has evolved, from older methods to today's diffusion models guided by text.
Right.
Interestingly, they found even a simple baseline approach they called blended latent worked surprisingly well for this mosaic task, sometimes better than models specifically fine-tuned for general intainting.
Really? Why?
They think it's because the base text-to-image models, like Flux, already have a pretty good built-in understanding of spatial layouts and how objects relate in a scene, which helps with this grid completion task.
Fascinating. Okay, so how do they actually build this mosaic in the latent space? You mentioned encoding.
Right, so you take your reference image, the toy car, and encode it into its latent code. Let's call it LR.
Okay.
Then you basically tile this LR code to create a bigger latent grid, say M rows by N columns. But crucially, the spot where you want the new image generated, off in the top left panel, you initialize its latent code to all zeros. It's a placeholder.
Got it. So the latent grid has the car's code repeated everywhere except one zeroed out spot.
Exactly. Then it follows the standard diffusion process, add noise to this whole latent grid, and then iteratively denoise it. But they use a mask so that during denoising, only the latent code for that target panel, the zeroed out one, gets updated. The others stay fixed, constantly providing the reference.
Clever. Now, you mentioned enhanced attention mechanisms. Cascade attention, that sounds important. What is it?
It is. Cascade attention is really one of their core technical innovations. Think of it as making the model look at the reference subject images in the mosaic in a smarter way. It's iterative, and it works from coarse to fine detail.
Coarse to fine. How?
So inside the model's attention layers, where it decides what parts of the input are important, they do two things. They keep the normal attention that looks at fine details. But in addition, they create downsampled, sort of blurry versions of the attention queries and keys.
Okay, like a lower resolution view.
Kind of, yeah. This lets the model get a more global sense of the subject's overall shape and structure from the reference panels. Then they take the results from this lower res global view, scale it back up, and add it to the results from the normal fine detail attention.
Ah, so it combines a broad overview with the detailed look.
Precisely. It's like looking at the subject from far away and up close simultaneously in each step. This helps tremendously in keeping the subject's identity consistent while still generating sharp details. They found this multi-scale approach really improves faithfulness.
And it doesn't add much computational cost.
Apparently not significantly, which is great. They mentioned the subtle differences from positional encoding between the scales also help preserve nuance. It's a very neat architectural tweak.
Definitely sounds like a key piece. They also mentioned meta prompting. What's that about? Is it just fancy prompting?
It's a bit more structured than just being fancy. They realize that how you write the text prompt really matters, especially with this unusual mosaic input. Meta prompting is their system for formatting prompts effectively.
Okay, like a template.
Sort of. For that toy car example, the prompt might be something like, this collection shows a colorful toy. Image 1 shows the toy in a jungle. Image 2 through image 9 show its colors. See those placeholders like image 1?
Yeah.
Those likely correspond to the panels in the mosaic. It gives the model explicit anchors, connecting the text description to the visual layout of the repeated subject. It helps guide the generation more precisely.
Right, tailoring the language to the input structure. Makes sense. So they have this whole system, latent unfold. How did they prove it actually works well? What did the experiments show?
They did quite thorough evaluations. Quantitatively, they used standard metrics, things like ClipI and Dino, to measure how well the generated image matches the original subject's identity.
Okay.
In Clip-T to see how well the image matches the text prompt. The results tables show latent unfold performing very competitively, often better than established methods like IT adapter, immediate control, or that diptych method we mentioned earlier.
So the numbers look good. What about people? Did they do human studies? Sometimes the metrics don't tell the whole story.
They did. They had people compare images from latent unfold against omni-control and diptych. Users rated things like identity preservation, how well it matched the prompt, and just the overall image quality.
And
Latent fold came out on top pretty clearly for keeping the subject's identity and for overall quality. Text alignment was about on par with omni-control, better than diptych, so people preferred its output too.
strong validation then. Did they do ablation studies? Removing parts of their system to see what impact each piece has.
Yep, essential for understanding why it works. Their ablations confirmed a few things. The 3x3 grid seemed like a sweet spot. Removing the background from the input subject image actually helped text alignment, interestingly.
Oh, really? Okay.
And crucially, adding their cascade attention mechanism gives a big boost to identity preservation, confirming its importance. Meta-prompting also helped identity, but maybe slightly reduced text alignment, sometimes a bit of a trade-off there.
Okay, that paints a clear picture of how the components contribute. Now, the paper mentions it's not just for generating new views, but other editing tasks too.
Absolutely, that's a big, plus the versatility. They show it working for stuff like seamlessly adding a logo onto an object.
Uh-huh.
Virtual try-on, putting clothes onto different generated people. They highlighted that it did a great job preserving the fabric details and texture, even without needing any 3D models of people.
Wow, that's impressive for try-on.
Yeah, and also general subject insertion or replacement, like putting that toy robot into a specific room scene from the prompt, or placing an object on Mars. They did note it works best if the area you're changing is reasonably large and somewhat central.
So it's quite flexible. Did they show style transfer as well?
They did. They included examples where they applied artistic styles like Van Gogh or traditional Chinese ink wash painting to the generated subjects. It shows the method can handle appearance modification alongside context changes.
Okay, great. So for our listeners, let's quickly summarize the key innovations here, the main academic takeaways from Latent Unfold.
Right. So number one, it's training free and doesn't need tuning at inference time. Big efficiency win.
Check.
Two, the whole mosaic image completion idea is fundamentally novel framing.
Yep.
Three, showing that iterative replication in the mosaic boosts identity preservation. Got it. Four, the cascade attention mechanism for getting both consistency and detail. That's a significant technical contribution.
Uh-huh.
Five, the meta-prompting strategy for guiding the model effectively with this mosaic input.
Right.
Six, demonstrating it work across a whole range of tasks, generation, editing, style transfer within one framework. And finally, seven, it's just a more minimalistic, resource-friendly approach overall.
Perfect summary. So wrapping up this wipe dive, the Flux Already Knows paper really shows a clever path forward for subject-driven generation. The core ha is using that mosaic structure to unlock the existing knowledge in these big models, bypassing costly training.
Exactly. From an academic view, the real complications are those techniques like cascade attention and meta-prompting. They push the boundaries of how we can control these powerful generative models without constantly retraining them.
Which leads to a final thought for you, the listener. What are the implications when advanced image generation and editing become possible without specialized training for each subject? How might this training-free approach change things in creative fields, or even research directions in AI? Does it shift the focus away from massive data collection towards smarter architectures and better ways of talking to the AI through prompts and inference techniques?
Definitely something to think about. The landscape is certainly evolving fast.
It is indeed. We highly recommend checking out the paper if you want to go even deeper. Thanks for joining us on this academic deep dive.